We want to look at this simple question from chemistry. It is from the limiting reagent. So the question says magnesium oxide reacts with dilute sulfuric acid as shown below. So you have magnesium oxide there reacting with that sulfuric acid to form magnesium sulfate and water. Now they are saying 600 grams of magnesium oxide was reacted with 980 grams of dilute sulfuric acid. Question 1 says determine the limiting reagent in this reaction. Now what you should know is that a limiting reagent is a reactant. Okay, so it is between these two guys because it is a reactant. So it is a reactant in a chemical reaction that is present in short supply. So it finishes first before the other reactant gets to finish. All right. Now, step number 1, when determining the limiting reagent, the first thing that you want to do is that you want to balance the equation that you have. So let's try to balance this equation that we have here. Let's see. Magnesium, we have 1 atom of magnesium. This side as well, 1 magnesium. Oxygen, 1 plus 4, 5. Oxygen this side, 4 plus 1, 5. Hydrogen, 2. Hydrogen, 2. Sulfur, 1. Sulfur, 1. So this is a what? It's a self-balanced equation. Of course, feel free to, pause the video, copy the question, attempt, and then, So, determine the limiting reagent in this reaction. Now, we've identified that this is a self-balanced equation. So, if it is a self-balanced equation, I'm sure you can see that you can agree with me to say there is a 1 here, the balancing figure here is 1, the balancing figure here is 1, the balancing figure is 1, the balancing figure is 1. So the mole ratios here are 1 to 1 to 1 to 1 to 1. Okay? So remember, the limiting reagent is between these two guys. It is a reactant. Now with the reactants that we have magnesium oxide, so MgO. We also have what? Sulfuric acid. That guy there. Now we are saying that the mole ratio, okay? The mole ratio is 1 to 1. Their balancing figures are 1 and 1. Now as long as the mole ratio is 1 to 1, all you have to do is just calculate or find their number of moles. The one that is having the smallest value is the limiting reagent. Is that clear? Yeah. So let's find their number of moles. In this case, because the mole ratio is 1 to 1, between the two, the guy that will have the smallest figure or the smallest value will be the limiting reagent. So I'm hoping you've been attending those tuitions or lessons or whatever. So we know that number of moles, N equals what? The mass over the what? Over the molar mass, right? This is the formula for number of moles. So we are saying number of moles will be equal to, what is the mass given for magnesium oxide? The mass given for magnesium oxide is 600 grams. So we are saying 600 grams. Now what is the molar mass of magnesium oxide? So magnesium oxide, MgO. Alright, magnesium oxide. So how do we find the molar mass? We do that. Alright, oxygen, there's 16. If you go to the periodic table, there's 16 on top there. Now when you say 16 times, in this case there's a 1 here, 16 multiplied by 1, you get 16. Magnesium, there's 20 what? 23, right? So when you say 23 times 1, you get what? 23. Now from here, you are just going to add these guys. So, magnesium, we have 24 on top there. When you go to the periodic table, the value on top of magnesium, the mass number of magnesium is 24. So 24 multiplied by 1, you get 24. So when you add 24 plus 16, you're going to get what? You get 40. So here you are saying you have 40. So the number of moles in this case will be equal to what? So when you say 600 divided by 40, you are getting 15. So the number of moles of magnesium oxide, we are saying we have 15 moles. We leave it there for now. We go to that guy. So again, we find the number of moles of this guy. So we know that number of moles equals mass over molar mass, right? Am I making sense? If I'm making sense, click that follow button. So number of moles equals mass over molar mass. Now we are saying number of moles equals, what is the mass given for dilute sulfuric acid? It is 980 grams. So the mass is 980 grams. What is the molar mass of sulfuric acid? So we have H2SO4. So we do this, I like to call this the staircase method. Oxygen, when you go to the periodic table, there's 16 on top. 16 times 4, you get 64. There's 32 sulfur. 32, in this case, there's an invisible one. 32 multiplied by 1, you get 32. Hydrogen, there is 1. 1 multiplied by 2, you get 2. When you add everything, you get what? You get 98, right? You get 98. So the molar mass here is 98. And so the number of moles of sulfuric acid are going to be 10 moles. So remember, I said that when the mole ratio is 1 to 1, just calculate their number of moles. The guy that is having the smallest value is the limiting reactant or the limiting reagent. In this case, our limiting reagent will be what? Excellent. This guy, sulfuric acid. So we have to tell the examiner. So you are saying, therefore, sulfuric acid or dilute sulfuric acid, H2SO4, is the limiting reagent or reactant. If the question was which reactant is in excess, the answer would have been magnesium oxide, because it is having more number of moles than sulfuric acid. Okay? We only do this, we only calculate their number of moles if the mole ratio is 1 to 1. But then if the mole ratio is, say, maybe 1 to 2, we are going to do something else. Okay, I'll answer a question on that. So just ensure that you keep following me. Now, question B. This is question A. Question B. Question B says what? Question B says calculate the mass of magnesium sulfate that was obtained at the end of the reaction. Where is magnesium sulfate? It's this guy right here. So what mass of this guy was obtained at the end of the reaction? Now, what you must know is that the limiting reagent determines how much of the product will be formed. So in this case, sulfuric acid will determine how much of magnesium sulfate is going to be formed. So we are saying because sulfuric acid, H2SO4, is the limiting reactant, it will determine how much of magnesium sulfate is going to be formed. What are their mole ratios? What are their balancing figures? There's one here, there's also one there. So we say 1 to 1. What do we want to do here? We want to calculate the number of moles of magnesium sulfate, because we know that the number of moles of sulfuric acid are 10. So it means that the number of moles of magnesium sulfate are also going to be 10 moles. Now that we've found the number of moles of magnesium sulfate, we are going to find its mass, because we know that number of moles equals mass over molar mass. Is that okay? So the number of moles of magnesium sulfate, we have them, it's 10. Now what is the mass of magnesium sulfate? This is what we're looking for. What is the molar mass of magnesium sulfate? So we do that staircase method again. We do this. We drop this there, we drop this there, we drop this. Oxygen, there is 16. 16 multiplied by 4, you get 64. Sulfur, there is 32. Multiplied by 1, you get 32. Magnesium, there's 24. 24 times 1, you get 24. So when you add everything there, you are getting what? 4 plus 2, 6, plus 2 plus 4. 6 plus 4 gives us what? 10, right? So you say 0, remainder 1. 6 plus 3, 9, 10, 11, 12. So you get 120 there. Now when you cross multiply, the mass of magnesium sulfate will be equal to 1,200 grams. 1,200 grams. Am I making sense? Yeah, so if I'm making sense, follow. Now, the last question says 1,008 grams of magnesium sulfate was obtained at the end of the reaction. All right? Now, you must listen on this one. Listen. So they are saying 1,008 grams of magnesium sulfate was obtained at the end of the reaction. Calculate the percentage yield. Now, how do we calculate the percentage yield? So what is the formula for percentage yield? So to calculate for percentage yield, we say the percentage yield, let me erase this part. So to calculate for the percentage yield, we are saying percentage yield is equal to the actual yield. The actual yield divided by the theoretical. The theoretical yield multiplied by 100%. So that is the formula for percentage yield. So they want the percentage yield of what? They're saying 1,080 grams of magnesium sulfate was obtained at the end of the reaction. Calculate the percentage yield. So we're saying this is the formula for percentage yield. Now listen, because they've said this amount was collected at the end of the reaction, what they've said was collected is the actual yield. If you can remember, we've calculated this mass for magnesium sulfate. So what we've calculated is its theoretical yield. What they've said was given is the actual yield. What they've said was obtained, is the actual yield. What we have calculated there for magnesium sulfate, that is its theoretical yield. So we are saying the percentage yield here will be equal to the actual yield is 1,080 grams. The theoretical yield we've calculated, it is 1,200 grams multiplied by 100. So the grams there will cancel. Now what is 1,080 divided by 1,200? So we are getting 0.9. So 0.9 multiplied by 100. So the answer will simply just be equal to 90%. So 90 will be the answer. Hope you've understood, hope you've enjoyed. Let me see your questions in the comment section, and of course, study for those exams. Until then, bye-bye.